Children, now we will see linear list arrays. Now we will see linear list arrays. So how this linear list or arrays, refers to a named list of a finite number of similar data elements. You see the definition. It's a named list of a finite number of finite number of similar data elements. Okay, similar data elements. And now each of the data element can be referred respectively by a set of consecutive numbers. We know when we store anything in the list, you will be representing the first element. Suppose your list name is L, you will be representing it as L of 0. That is the first element. Like that, here also they have given always array elements start storing from 0 to n minus 1. That is what is expressed here. This linear list or array. So whatever I told as definition for arrays only is applicable here. If the name of the linear list is 10 elements, if the name of a linear list of 10 element is LIL, list LIL, then its element will be referenced like this: LIL of 0, 1, 2, 3 and so on. 9, 10 means up to 0 to n minus 1. So arrays can be it may be one dimensional, two dimensional or multi-dimensional. So then now Python what will do is in C, C++ and all, array concept is very clear. But here what they are going to do is see, it may be one dimensional, two dimensional or multi-dimensional. In Python, arrays are implemented through list data type. Okay, list data types as linear lists or through NumPy arrays. We'll see it will be list data types as expressed as linear lists or through NumPy arrays. We'll see how we are going to express. Okay. Now we will see the way the types of linear data structures. The three types of linear data structures are link stacks, queues. Stack what I told is given already. I said in the previous video also. Stacks data structure refers to the list stored and accessed in a specific way, where LIFO, that means, or LIFO, lost in first out. Yeah, I told you, see the diagram. Think of this is your that idli stand. In that, plates are arranged like this. If you wanted to see where, suppose you are going to add a new plate. Suppose only 5 plates you have kept. Still the spindle is empty. If you wanted to keep the 6th plate, where you will keep? You will keep on the top. So LIFO means what? Lost in first step. Even after boiling, I have to take the first plate only out. I can't take this lost plate. Okay, so one by one I have to take it out, then only I can go to the lost plate. So lost in first out technique is applied here. See, you have to apply this technique in the program. Okay, now theoretically they have given, don't think that this theory itself is enough. You have to apply this LIFO concept and on stacks as a program. So in when you see in stacks, insertion and deletion takes place only at one end. Yeah, on the top. Actually on the top only insertion, new plates can be added, and I wanted to remove means deleting plate also will happen on the top of the stack. I hope you are all understanding what I wanted to say. Okay, so always it will the operations will happen on the top of the stack. So stack means LIFO technique. The next one, when you say queues, okay, think of you're all standing in a queue to get correction from me or your other subject teachers. So okay, our Kavinvel is standing first in the queue. So what will happen? So how the queue will move from Kavinvel, and think of our Roshan is standing in the last. Okay, so now Kavinvel too, Kavinvel has FIFO. He has come first for getting sign. So he is the first person in the queue. So look at the diagram, and he'll only go out first. So first in, first out. but Roshan is standing there in the last, so he has to go only after, suppose 6 are standing in the queue. Roshan has to go only as a 6th student. So okay, so what is happening? Now I want now our Subharti is coming for correction. He has to stand only, go to the back and stand after Roshan. So now where the insertion is happening, insertion means what? The new entry. Okay, the new entry. In stacks, I said the new entry will happen only in the top. Only in the top of the stack. Here in the queue I am saying now Sivabharati is coming newly for getting correction. He has to go to the last of the queue and he has to stand. So whomever is standing in the first, they will be getting the correction first and they'll go out. Whereas the insertion will happen in the, insertion will happen in the back end. We call it as rear end. We call it as rear end. Where the deletion will happen after Kavinvel gets signed from me, he'll be going out. That means in a queue one person is reduced. So this is deleted. Kavinvel is deleted now. So he will go out. So FI, FO, first in, first out. So this is what we call as the queue technique. So this is front end. First position we call it as front. These words are very important. Key words are very important. And the last person standing in the queue, we call it as rear end. Okay. Only newly whomever is coming, they'll join only in the back. They can't come and like how you will go and stand in the assembly. There lots of things will happen. In between you will go and join. Okay, now here it will not happen in the queue. Only you have to go to the last and stand. Okay, this is what is the technique behind queues. And now let's see the linked list. Okay, the next one is linked list. Okay, we'll see that how it is working. Linked list. I said list means what? So again it's a special list of some data elements. Some data elements linked to one another. So how the link will happen? First I wanted all you all to see the diagram. See here, these boxes are called as nodes. Okay, each box has two parts. Look at, one is the yellow part and the other one is something shaded. This box like thing. So this yellow part is called as info part. Everywhere this is very important. Even in C++ we taught the same thing. No change at all. In whatever OOPS language this technique is coming, this data structure chapter is coming, this is only the theory part. See now this is this info part. Info, this is info means suppose I wanted to store the value 10 here, so the 10 is info. What is this next? This represents the address of the next element. We call this box as node. Okay, node is divided into two parts. One is the info part, another one is the address part. They have taken that as next. Next means what? It is going to connect the next element. You know what the main purpose of linked list is? In arrays I told you similar data type elements are stored under a single name. When we are talking about linear list, I said like that. Here also the linear list, but array requires consecutive memory location, whereas linear list, suppose we don't know where the elements of the list are getting stored. Okay, it may store in think of the memory address, it is different. Just for example I am saying, first node, suppose this is getting stored in the 10th the address, memory address, say something 1000, and this is stored in 2000, and this is stored in 5036. So but all these are under a single list. How can I connect all these elements are under the single list? So this next represent the address of the next node. The address of the next node. So here information next means it goes and connects the next value which is which has to come as a part of the list. I think you're all following me, else doesn't matter. We have so many examples and others are going to come, you will be knowing. So now another thing is now Yeah, see there are two types of linked list. One is singly linked list and doubly linked list. That means both the sides it will be linked. Now in singly linked list, nodes have one reference pointer. That is next. Only one reference pointer will be there pointing to the next node. Whereas you see in doubly linked list, when you see, you will have like this. See, you will have like this. See the definition in doubly linked list, you have two reference parameter, that is the previous and next. The node is divided into three parts. One is previous address, next address, and middle is the info, the value. So it will be connecting with the previous value and the next value like that. So this is, singly linked list. This is doubly linked list. That means a value. So when this linked list concept will work, as I said just before, when see, we can't say always your elements, whatever you are storing under a list, will go and get consecutive memory location. It may be stored in different memory locations. So in that case, how the system will identify all those elements will come under the single name or list. So that will be represented by means of this address. Please kindly go through, you will be understanding what is the basic concept behind linked list.